Methane is a powerful greenhouse gas. Each molecule of methane, CH4, is equivalent to 84 molecules of carbon dioxide, according to Climate Change Connection. An article at phys.org, published on February 3, 2025, is titled, Satellite Data Analysis Uncovers Top 10 Persistent Methane Sources. Here's the lead. Quote, a list of the top 10 global regions where natural or anthropogenic sources emit methane on a continuous, persistent basis was recently published in Atmospheric Chemistry and Physics. End quote. 4 paragraphs into the article at phys.org, we are informed that the research focused not on oil and gas operations, coal mines, or poorly managed landfills. These so-called super emitters release disproportionately large amounts of methane during short bursts. In contrast, this research focused on more or less constant methane sources. According to Klaus Zahner, the European Space Agency's mission manager for the satellite Sentinel-5P, quote, Sentinel-5P is currently the only satellite that provides the feasibility to detect methane sources on a global scale and on a daily basis, end quote. Satellite 5P was launched in 2017, and it carries the state-of-the-art Tromponi instrument. This instrument is used to map trace gases, including methane. Beneath a section titled, Why is Methane Important?, we are informed that methane is the second most important greenhouse gas after carbon dioxide. It is found naturally in the atmosphere, although its steady increase in atmospheric concentration is driving planetary warming. Whereas methane was found in Earth's atmosphere at 680 to 790 parts per billion until 1850, it has increased to more than 1,900 parts per billion. Furthermore, there has been a significant increase in anthropogenic methane emissions during the last 2 decades. The article at phys.org concludes with the expected advice. Quote, reducing methane emissions is therefore an important strategy for tackling the causes of global warming. End quote. I agree that reducing methane emissions, as well as the emissions of other greenhouse gases, is a fine idea. However, the path from nearly 2,000 parts per billion of atmospheric methane to pre-industrial levels of less than a third that number is no easy task. As I have mentioned more than a few times in this space, terminating the set of living arrangements to which we have all become accustomed is hardly an easy task. Never mind the attendant ethics associated with the deaths of unprepared humans and ultimately all life on Earth. Are we going to vote on terminating this set of living arrangements? That seems unlikely. I now turn to the peer-reviewed open access paper. Published on September 19, 2024, the paper was written by 7 scholars entitled Automated Detection of Regions with Persistently Enhanced Methane Concentrations Using Sentinel-5 Precursor Satellite Data. The abstract provides a comprehensive overview of the study. Quote, methane is an important anthropogenic greenhouse gas, and its rising concentration in the atmosphere contributes significantly to global warming. A comparatively small number of highly emitting persistent methane sources are responsible for a large share of global methane emissions. The identification and quantification of these sources, which often show large uncertainties regarding their emissions or locations, are important to support mitigating climate change. Daily global column-averaged dry air molecular fractions of atmospheric methane are retrieved from radiance measurements of the tropospheric monitoring instrument on board on the Sentinel-5 precursor satellite with a moderately high spatial resolution, enabling the detection and quantification of localized methane sources. We developed a fully automated algorithm to detect regions with persistent methane enhancement and to quantify their emissions using a monthly tropospheric monitoring instrument atmospheric methane dataset from the years 2018 to 2021. We detect 217 potential persistent source regions, which account for approximately 20% of the total bottom-up emissions. By comparing the potential persistent source regions in a spatial analysis with anthropogenic and natural emission databases, we conclude that 7.8% of the detected source regions are dominated by coal, 7.8% by oil and gas, 30.4% by other anthropogenic sources like landfills or agriculture, 7.3% by wetlands, and 46.5% by unknown sources. Many of the identified potential persistent source regions are in well-known source regions, like the Permian Basin in the USA, which is a large production area for oil and gas, the Bowen Basin coal mining area in Australia, or the Pantanal regions in Brazil. We perform a detailed analysis of the potential persistent source regions with the 10 highest emission estimates, including the Sud wetland in South Sudan, an oil and gas dominated area on the west coast in Turkmenistan, and one of the largest coal production areas in the world, the Kuznetsk Basin in Russia. The calculated emission estimates of these source regions are in agreement within the uncertainties and results from other studies, but are in most of the cases higher than the emissions reported by emission databases. We demonstrate that our algorithm is able to automatically detect and quantify persistent localized methane sources of different source type and shape, including larger scale enhancements such as wetlands or extensive oil and gas production basins." End quote. The abstract does not include all relevant information, of course. In addition, its use of scientific jargon interferes with understanding by most people. The first paragraph of the introduction provides clarity as it cites peer-reviewed evidence. Quote, "Methane is the second most important anthropogenic greenhouse gas after carbon dioxide, and its increasing concentration in the atmosphere, which has accelerated in recent years, contributes significantly to global warming. Due to its shorter lifetime and higher global warming potential compared to CO2, the reduction in methane emissions can contribute to mitigation of global warming." End quote. Of course, quote, "the reduction of methane emissions can contribute to mitigation of global warming," end quote. Does that mean we will respond as a society with the necessary reductions? What would that look like for you and me? Stating that we could respond does not mean we will respond. Considering the views and actions of the people currently in the White House, including President Trump and his tech buddy Elon Musk, I see no evidence of leadership in reducing emissions of any greenhouse gases. When Trump and Musk lead the way in reducing emissions, perhaps the masses will follow. I doubt such leadership is forthcoming.